What's up, James? How you doing, buddy?
Great. How you doing, Eric? Good to be here.
I am good. Welcome to Serverless Office Hours. I'm so excited you're out there. If you've never joined us, shame on you. This is something we do every Tuesday at 10 a.m. Pacific time. I would say PDT, PST. I can never keep it straight. So just Pacific time, whatever relatively that happens to be for you. Good luck with the math. If you don't know it, ping James directly on Twitter. He's good with this kind of stuff. So, James, thanks for joining me. Let me bring up our screen and show folks what we're going to be talking about today.
Yeah.
Of course, this is Serverless Office Hours. And I want to introduce you, although most people know you. This is my buddy, James Bezic. Did you hear it? Did you hear that? I said it exactly right. Wendy would be so proud. She would. This is James Bezic. He's a principal developer advocate, also one of my buddies. We've been working together on the same team forever. James, tell us what we're talking about today.
So this is a really interesting topic for me. We're talking about producing a serverless GIF generator. But really what we're talking about is parallelization with Lambda. How do you make a long-running compute task a lot shorter with Lambda and really using the same sort of code? So it's a really exciting topic.
Yeah, I was pretty excited about this. I've seen it in action, and very honestly, it's like, whoa. I mean, I know in my head that it'll do this stuff. I just hadn't built this out yet, and it's pretty mind-blowing. Let me jump up here real quick. And oh, hey, I don't know how that got in there. I'm sorry, James. That wasn't supposed to actually be in there. But since it is, this is my buddy Bez. And I'm so happy that you're with me today. It's an accident, you know it is. This would not have actually appeared in there already. I'll leave this
by
here.
Accident, yeah.
Yeah, if anybody wants to screen cap this real quick, we'll wait just a second. Okay, here we go. All right. Yeah, today we're going to be talking about, like James says, this is last week. If you missed it last week, Julian and Sam, Sam is one of our principal solutions architects. Julian's one of our developer advocates. They talked about processing DynamoDB change data. So that really talks about like off the back end, when something happens at Dynamo, how do you process that? What do you do with that? What kind of power you can do that? So if you're using DynamoDB, I really encourage you to go back, check it out at our ServerlessLand YouTube channel, or go to serverlessland.com. We have links to it. So check it out there. We keep everything in a playlist. So, and then of course, this week is the GIF creator. Now, is that GIF or GIF? What do you say?
GIF. It's got to be GIF, surely.
I don't agree. I think it's GIF. But I don't know. So yeah. So and I'm not smart. So obviously the two of us, you have the British accent, so you're obviously smarter. So all right. So I'm gonna turn it over. Are you ready for your screen to come up?
Yeah, absolutely.
All right, let's do it. I'm gonna add your screen, and here we go.
Great. And obviously, anyone watching can ask any questions along the way, and we'll be happy to answer anything you like about this solution or serverless or Lambda or whatever you please.
That's right.
So with this solution right now, there's this URL I put up called gif.jbez.dev. It's just a place where we're hosting this example. And the idea is this would be like a Netflix player or a Prime Video player or any of those types of streaming solutions. And so you've got a video here, and it's running, in this case, it's just a video that Chris and I did a while back. And whenever you play a video on Netflix, typically you have a player that looks like this. When you drag or fast forward, you see a still frame of that point in the video, but also this animation on the right-hand side that gives you a preview of what's coming up at that point in time. So to make this work in those players, they've got the original video file like this file here, which is just coming from YouTube. But they've also got all of these extra frames and all of these different GIF animations. Now, the way I've set this up in this example is there's a GIF every 30 seconds in the video. So as I drag through this, you can see we're at 570, and it just rounds up to the nearest 30 seconds that it's currently at. But you do get one frame per second of video. So for a 2 or 3 hour video, I took a reInvent keynote. You end up with a lot of different files here, and this can actually be a fairly compute-intensive task. Now, what you can do, if I go to my Cloud9 settings, if you typically do this with a server-based approach, I've written a fairly simple script here that does this for you. So you'll find all this in this GitHub repo. I think we have a link for this, don't we, Eric?
I will get it. Serverless GIF generator, right?
That's the one. So you can look up all the code there, but I've just basically cloned this repo to my Cloud9, not Cloud9 instance, Cloud9 instance. That'd be a good product.
Serverless GIF. What is it? Serverless GIF? I'm sorry.
It is a serverless dash
GIF generator.
dash generator. Yeah.
All righty. Thank you.
Generator.
Generator. Funny. You're killing me.
So if you go into the server example directory there, you'll find this very small node script, and it's using a library called FFmpeg, which is a really useful library for processing video and doing this sort of editing. And so this script, I'll walk you through very quickly what it does. It takes this video that I've got called test.mp4. If I scroll down.
I like that. Coder Son says it's GIF. I'm with that. We're going with that.
I mean, let's pick that one, yeah.
Yeah.
And so we're going to use this FFmpeg command line format to basically chunk up this video into these 30-second segments. Now, to run this, remember, this is the server-based example because I'm on Cloud9. And so what I can do is I've got this test MP4 file. I'm just going to say run node app.js. And it's going to go through this file and create one GIF at a time. And it's dropping these output files in an output folder. And you'll start to see the frames, the individual JPEG frames appearing there. So this is the server-based approach. And this, to run an entire video of 2 to 3 hours, I found took about 20 minutes. Even if I increased the amount of memory on the Cloud9 instance, it's not a very, very fast process. Because
it's doing linear, right? One after the other? Okay.
Yeah.
All right.
And obviously, this is just with one video as well. So once I could modify this script so that if there was more than one video, once it ends one, it can continue the next. But
hey, James, we've had a request. Can you blow it up just a little bit? Sorry about that.
Oh, sure, yeah.
You might hide your files.
Yeah, let me see if I can figure out how we do that.
It's on the browser file. Browser view is the best way to go.
Oh, browser view.
Yeah.
In here?
No, view in the browser. That's in the Cloud9 files. Go to the view in the browser.
I'm on a PC.
Oh, my goodness gracious. So, yeah, +1. Okay, yeah, there you go.
I'll do that. Okay, so hopefully you can see that. Okay, you don't need to see the output here. It's just showing these GIF files being created. I can't speak today. So I'll stop that process for now, and you get the sense of this is a slow process. So if you were someone like Netflix or Prime Video or any of these streaming services, you obviously get a very large number of these video files appearing every day, and you need to better prep them and put them onto your system. And so what I wanted to show you was a serverless approach to doing the same thing here. I'll show you how this works very quickly. So I've got two S3 buckets that I've set up. One is a source bucket where I'm going to put these MP4 files.
Can you blow that up too, bud? Sorry, okay. I'm the blow up police.
Does that work?
So yeah, that's good. That's readable.
Okay, I'll do the same here. Oh, it did.
Yeah, that'd be great. Thanks, sir.
So we've got this source S3 bucket where you put your MP3 files, and the destination bucket which generates all of these GIF files.
And of course, we mean MP4 files.
Yes.
Yes. MP3 would just be audio, and you wouldn't get any interesting GIFs out of that. So
yeah, please use MP4. And then all that's happening is this front end is then going to that bucket, and all of the objects are set to public, and it's simply pulling the relevant GIF animation or JPEG frame, depending on what you selected here. But if we go back to the bucket, what I can do is upload one of these videos from my Cloud9 instance. I'll go back to that instance, and I've got a directory called movies. I've put a series of differently sized movies in there. I'm going to upload one of these to that S3 bucket. So I'm going to say I want to copy, let's say day1.mp4. I just take the name of the bucket. I'll copy that to there. So I'm going to copy this MP4 file to the source directory. Now, this is a fairly fast copy operation because Cloud9's on the AWS network. It's not uploading to my home here. So that makes it very quick. And what you find here, if I just refresh, you see this day one folder has now appeared. And it's already got it's got 518 objects already. There'll be more as it starts to come through. But over the course of about 10 or 11 seconds, we'll start to see thousands of these objects appear in this bucket. What I can then do is I can take, this is called day one MP4. I'll go back to this example, change this out. I have to mark it as public, of course. I'll just go back to that bucket, day one, make public.
So, and you'll notice what he's doing is he's not making the bucket public. He's making the objects public. And this is a huge thing to note here because we get a lot of times people have public buckets and they get in trouble for that because anybody can read them. He's choosing the object and not the bucket. So
yeah. And in fact, if you wanted to do this in real life, you'd use CloudFront. But just for the sake of showing the demo, it's easier just to set it up this way. Right. So you'll see that now if I drag this around, you'll get the same GIF animations at each point in the video and the JPEG frames. And this was produced in and around about 10 seconds or so.
Same amount.
Same amount.
Yeah.
Now, what we can do here is that if I go back to my Cloud9 instance, I can, instead of just uploading one file at a time of these videos, let's just do all of them. So I've got several videos here, quite large. I'm going to just say recursive. I'll make this ACL public read so
there you go. Yep.
Be easier. So again, this is a really fast connection I have. It's uploading 724 megabytes in just a few seconds. If I go back,
can you explain that ACL public read real quick?
Yeah, absolutely. So what I did in the console, because I'd forgotten the first time around, if I upload an object to S3, by default, it's private. Now I want these objects to be publicly readable so that we can see them in my hosting application over here. Now you can do that in the console just fine. You just select the object and go to the actions menu and select make public. But you can also use this parameter on the CLI. And I'm a big fan. I don't know about you, Eric, but I'm a big fan of using the CLI when working with S3.
Yeah, and the ACL is access control list, right? So that's you're actually adding an access control list that says these particular, and it'll be very specific to these files. It's not going to say and everything else in the bucket. It is just the ones being uploaded. Yes, I'm also a huge fan of CLI. Yeah,
and so back in that the bucket where all of our GIF files are generated, if I go back to the top level and refresh, we'll see now that all of these new folders have appeared for all of these different videos. And again, the total execution time for the entire job was about 10 seconds, even though we had many more videos. And we could take any one of these and look at the contents. What you'll find in here are thousands of separate files for each one of the frames and each one of the GIF animations. Depends on the length of the video.
That's ridiculous. That is absolutely ridiculous. So if you did one of these files, I'm going to ask you a couple questions here, and throw in your questions here because let's stump James. I mean, really honestly. But if you did one of these files in the legacy, let's call it legacy, or in your earlier one with the server linear, that took what size was the file example you were using?
So that one there is let's see, we just. The day one was looking to be about 29 megabytes.
Okay. And how long did that take to process?
That one takes about 10 minutes. It's not actually a very long video, but the 3-hour video I did took more like 20 so minutes.
Right. Okay. So that's a great example. And how often are we doing, 5-minute videos, or how often, if you look on a Netflix stand or something like that, where instead of doing GIFs, maybe they're grabbing, hey, we want, 5 minutes of trailer. We want, some example stuff that you see when it comes up when I do the big window. They want to process that. That's a lot going on, and you're just dumping tons of videos in. If we're doing it in your linear way, it's more, I mean, you're talking days and days and days and days of processing.
Yeah. And so really, this is an interesting solution if you have lots of these types of videos, because while you could definitely take an EC2 instance and scale up a fleet to handle these sorts of jobs, there's nothing wrong with doing that. Then you have to manage that fleet and increase the fleet as you have more work to do. And there's overhead in terms of making it work. Right. Taking the serverless approach, all of this is triggered by something arriving in the S3 bucket. We're not being charged for anything when it's not running, and that Lambda handles the scaling up for you when more of those files arrive.
So let's, do you mind if I interrupt for a minute and talk out a little bit? So James and I have been talking about this. Hey, we have a question real quick. Is this through S3 object Lambda?
No. So this is just purely taking an event when a put object event is raised when the file is initially uploaded. I'll walk you through the architecture in a couple of minutes. It's a good question.
Right. So to be clear, the object lambda is when you do a get on an S3. So if James were doing a call to that, then he could do some work. But this is actually when you're putting data, and then it's actually invoking those lambda functions.
Right.
So James, you and I have been talking, and I was working on a project with elemental stuff.
Yeah.
All right. So you start to think about what are the and then maybe this is an afterwards, but I want to interrupt. How far can we take this? And one of the projects that James and I have been talking back and forth and working on is we've got a project where you can actually stream to an elemental server, and then it'll convert it to an MP4, and then we could drop it in a bucket, and James could break it down into GIFs, and then we're also we transcribe it using Amazon or we use transcribe, AWS transcribe, and then we can actually translate it, right? So and then we create the SRT files that are closed caption files, right? So you have this ability to, I mean, this is a full-on serverless media, modification system, or that you could take to. I mean, there's no end to the things you can do with the serverless services we have, and James is giving you the framework to get that started. I just whacked my desk with my ring. That hurt. Was that on screen? Was that live? So we got a question, SNS. I'm not sure what you're asking about SNS, or could you use SNS?
Yeah, actually, I'll cover that in a few minutes, because right now I'm using EventBridge to do this, but I'll talk about different ways that you can approach the same problem as we start to chunk up the work. But what I wanted to show you next was the actual Lambda function that does all this work, because it's surprisingly straightforward. Once you've got that original script running from, this is our server-based script that we originally wrote to do the work, then all I need to do is have a Lambda function that more or less is running the same code. But there's a couple of slight differences. So there are two Lambda functions involved in this solution. The very first one, when that S3 object arrives and it calls the put object event, that comes to life and it looks at the length of the video. Let's say you've got a video of 10 minutes. And then it's got an environment variable that says how short the chunks should be. So I'm saying they should be 30 seconds. And it goes through for the length of that video and puts events on EventBridge saying one is for 0 to 30 seconds, the next is for 31 to 60 seconds, 61 to 90 seconds, and so on and so forth. And so that particular Lambda function, all it's doing is generating events representing 30-minute sections of the video. Now, this second Lambda function, which is the part that does the work, this is the worker function, is receiving those events from EventBridge, and it uses those parameters to know where to start and where to end in the video. So the Lambda function itself is only ever responsible for one section of the video. So if an event comes in that's 31 seconds to 60 seconds, it will download the whole video from S3, just provide the GIF for that one section, put it back in the S3 bucket, and then go away. Now, the clever thing here is that EventBridge to Lambda is a really helpful scaling mechanism. So that first Lambda function is obviously creating a lot of EventBridge events. So you've got one every 30 seconds for the length of the video. When all of those events are received by the Lambda service then scales up this Lambda function, this second Lambda function, to process all of those events. So I can show you this in the metrics of this Lambda function as an idea. So when we uploaded those 5 or 6 videos, the 1 gigabyte or so, I'll just make this a bit bigger here. Hopefully you can see that. What you can see is we uploaded all of those files at once into S3, and that caused 394 separate Lambda invocations. On average, they took between 1 second and 6 seconds based upon this. And most importantly, when you scroll down, you'll see that the concurrency went up to 316 as well, because each one of those Lambda functions, if you run it through the steps of what happened, the first EventBridge event arrived, this Lambda function came to life, started processing the video. When the second event arrived, which would have been really almost exactly the same time, that first function is busy, so the Lambda service scales up another function to do the additional work. And it keeps doing this. So we've effectively got 300 or so events from EventBridge all around the same time, and the service responded by launching 316 separate instances of my Lambda function.
Yeah, well, I'd say the most important one, scroll up the top right there. No errors, baby.
Yeah.
Hey, We did have a question. Can you show the Lambda config? So how are you configuring this Lambda? So memory, things like that.
Yeah, so that's a fantastic question. So there's a few things that are subtle here. So let me show you just a bit of the code and I'll tell you about the config. So you've got this process MP4. Hopefully this is visible. If not, I can make this a bit bigger. I'll go a bit bigger, just hopefully that's better. This is very similar to the code that we saw earlier in the server processing version, but the key difference is it's loading data from S3. So that's one thing that isn't the same between the two, but it's still using FFmpeg to process the GIF animations. Now, FFmpeg itself is a fairly large library, and the easiest way to use this is to pull it in as a Lambda layer. Now, I go into this in a little bit of detail with the blog post, but there's a fantastic serverless application repo that will generate this layer for you. So in terms of configuration, this Lambda function refers to that Lambda layer. Actually, in the code tab, just a bit further here, this is my FFmpeg layer. So I'm not pulling that directly in and bundling it with my code, which makes it very easy to continue to see the code in my console. Now, when you're processing large amounts of video, typically you need more memory than you would use in a default configuration of a Lambda function of 128 megabytes. Now, this is something you can experiment with because you don't want to waste memory. It's easy to pick large amounts of memory without thinking about the configuration. But I've configured it to 4 gigabytes currently to download these videos and do this work. You could use Alex Castelboni's Lambda Power Tools package to see what variations of memory work best for you. So I found that 4 gigabytes was a good trade-off for the length of the execution versus the amount of money that I wanted to spend on memory. And then just there, note the timeout as well. So you'll notice earlier when I said when we did one video, it was about 10 seconds. And when I did 6 or 7 videos, the whole job took about 10 seconds. Well, the reason is it's the length of a single Lambda invocation that really sets the length of the entire job. So whichever one runs the longest is the length of the whole job. So it won't take more than 30 seconds, but typically on a 2 to 3 hour video, I've seen it can take up to 10 to 11 seconds to process the video. And a lot of that is because it's downloading all of the content from S3. So
a couple of questions coming in, and I think you answered some, but let's make sure. Yeah. So you showed the Lambda config, you talked about the memory and things like that. There was what was your reasoning behind using EventBridge instead of SQS?
Yeah, so now SQS you might want to use if you had hundreds and hundreds and hundreds of videos. Yep. Imagine you've got a vast, vast library. And in that case, what the limiting factor here is how fast Lambda can scale. Lambda can scale to up to 3,500 instances at burst when it first starts, which is an enormous quantity. I mean, it's really, right. In all of the examples where I've loaded dozens of videos, I've never even got close to going over even 1,000. But it's conceivable that you could have a quantity of videos where you go beyond that. Now, you could use provision concurrency to get around that if you needed to. But if you weren't so concerned about the immediacy of the videos, SQS could be a really good solution because you could queue up the work and start taking work as your Lambda environment starts to become available. And that would be a way of balancing an extremely large load versus how you wanted to configure your Lambda functions.
Well, so the next question, I think this answers it, is in a real world scenario, would 1,000 concurrency be sufficient or should that be increased? And that really touched it. Personally, I would probably, unless it is so sensitive, it has to be immediately out there, I would use SQS. You know, and protect your concurrency behind there. SQS batch, you know, run your batch to keep your function from getting overrun.
Yeah, I actually threw a very large amount of video at this, and I was surprised how, you know, it's very hard to get anywhere close to any of these limits. But definitely in a production case, SQS is a great alternative approach. Right. And it's actually fairly easy with this solution if you wanted to switch out the EventBridge solution with SQS. Now, the great thing about EventBridge is this scaling capability as well, because EventBridge doesn't queue anything. So what it does is it essentially gives you all of the events as they become available. And that's part of the reason why the scaling here is so efficient.
So we did get a question here. Dan_NBA said, are you using AVX2 with FFmpeg?
No, I'm not. And actually, that's something that's a really good point, because I wrote this code by really just naively writing a few lines of code. I didn't do anything to optimize anything here at all. And so actually, if you did use AVX2, or you went through this and found a more efficient way to handle the files, you could improve the throughput even further. I wanted to take a fairly conservative approach and make it so I wasn't doing anything behind the scenes to make this incredibly fast. I just went for a fairly vanilla setup.
So I'm grabbing the blog. There's a guy who wrote this blog on AVX2 and configuring AVX2. I don't know if you've heard of him. His name is James Beswick. So I'm going to post that blog in here if you're interested in what he's talking about. And that's getting a little more out of the processor. So yeah, AVX2, that's a great question. And something I would definitely look at if you're doing this kind of high process.
Yeah. So the other thing to think about with this is also cost. So, when we're using Lambda this way, we really are, we've got memory to configure, to think about. We've got the lead duration of each Lambda function to think about. We've also got very large numbers of invocations. So you want to think about the cost of doing this versus using something like EC2. So I used the pricing calculator, and I turned off free tier, and I added up I put in my parameters in terms of memory and number of invocations. And I found that for a 3-hour video, it cost me about 10 cents. So if I went through and figured, well, arguably EC2 might be cheaper because you could get an hourly rate on EC2. And even though the task takes longer, the overall aspect of it might be cheaper. But really the balance here is you still have to go through and manage the scaling of your EC2 fleet. And so I would argue that the automatic nature of this, the fact that it just handles the scaling for you, the cost trade-off, is a pretty good one.
So 2 questions for you. First one is, so if SQS, bring this up here. So if SQS would be introduced to the Arch, then it's S3 put event which invokes a Lambda, which pushes to SQS, and then the GIF generator Lambda.
You don't need to go through that first Lambda function, actually. You could go to S3 directly to SQS in this case.
But you still need the logic to break it down, though, right?
Yeah. So to do that where you create different messages, then you would need that Lambda function.
Yeah.
But there's definitely, you can also use SNS for this too. So it's worth mentioning that too, in terms of you want that first Lambda function as essentially a controller to set up the work for the worker Lambda functions. And so that you could arguably use SNS as well. One of the reasons I like using EventBridge for these kinds of solutions is that as I was building this, I thought about, well, I'd really need something like a DynamoDB table to keep track of the metadata of what I'm doing here. I want to know what video it belongs to, what the length was, when it was created, all of this additional information that isn't in the file itself. And so with EventBridge, that's very easy because I can create another target on an EventBridge rule that spawns another Lambda function that manages that without me having to modify that original Lambda function.
Yeah. So that kind of leads us into this next question. And I think I know the answer, but I want to hear what you say. This probably has a limit on video size, right? So it has to pull the entire video down. But go ahead.
Yeah. This is a good topic because essentially S3 to Lambda data transfer is free. So when I was building this, you've got this fact that you're pulling down the video many, many times to parallelize Lambda functions. But that data transfer cost aspect doesn't cost you anything. And although you've only got 512 megabytes of temp space, you have up to 10 gigabytes of RAM. Now with FFmpeg, you can actually stream the result into the service in memory. You don't need to write it to the temp space first. And so I was looking at what it takes to build a 10 gigabyte video. And I mean, it's pretty excessive. You'd have to go for a very, very, very long video at very high quality to hit those kind of limits.
That's right. Yeah, when you look at like you download your video from Disney Plus or something like that, where they do very high quality, you're still looking at about 1 gig. I mean, one and a half, maybe 2 gigs with a bunch of extras, things like that. So video compression is getting so good and quality. Okay, so this isn't a question, but I just like this. I'm so sick of managing EC2 clusters. I want a serverless as far as it gets me. Amen, brother. And I agree with you. And there we go.
Yeah. I think the S3 model as well is something I've personally, that was my way into serverless, because to me, it makes a lot of sense to start with something changing in your data environment. A customer uploads an invoice, or someone saves a movie file, or some data event happens in S3, and then you trigger your custom logic off the back of that. because essentially this is the purest form in terms of you writing business logic, that you can, if you can write it to work on one data item, then it can work on thousands.
That's right.
And so I think there's a lot of different use cases where you can use this S3 to Lambda pairing. And when I first started serverless, this was one of the tricky things because I came from EC2 and using Beanstalk for everything. And so you're trying to think about things in terms of how your code responds to one data item, and breaking up the work is really, I think, the easiest way to start understanding serverless. And certainly in this solution, I thought about this in terms of how can I break down the work? Because when I first started building this, I thought, well, this is a 2-hour video. You know, your Lambda function could potentially time out within 15 minutes. It was taking 20 minutes on my Cloud9 instance. But of course, if I can create parallelized workloads, they're effectively identical because they're simply just units of time throughout the video, then I could actually really reduce it to smaller and smaller chunks. And I think that's really the power of the serverless solution here.
Yeah, I agree. And going back to like how far can we take this out? You can actually take this and stitch the videos back together afterwards, make longer GIFs. You could do, you know, there's endless number of, you know, ideas here. There's another question here that I'm gonna grab actually. It says, can we introduce step functions to this architecture? If so, what would that architect look like? I'm going to challenge you to wait a week because we're actually going to continue this theme. Next week, we're going to talk about near real-time video processing using step functions. And several of our serverless heroes are coming in to talk about this. And we're going to talk about this whole architecture and what that looks like with step functions and a solution that they actually delivered to a customer to do this. So, but, you know, James, I don't know if you want to take any preliminary whacks at it or.
Yeah, you absolutely can. You know, I think this is one of the really traditional questions in the space about step functions. You know, should you bring step functions into a solution? And, you know, for very simple applications where you've just got one S3 bucket and one Lambda function, it's probably overkill to use step functions. But I think in many enterprise type solutions, step functions gives you such good control over the orchestration of what's happening. You can make a good argument that it's worth using in that case. You know, if this were a real system where you really were Netflix doing this, you'd want to know at any point if any one of these videos had failed for any reason at all. And, you know, currently I've not built that at all into this solution. Right. And so that sort of control that step functions gives you over the workflow, I think in many real solutions, you can make a very good case for it.
Yeah, and the direct integration, and you can do a lot of logic in the ASL itself. So you might even be able to drop a Lambda function or two in this. Not saying for sure, but I'm all and Rob Sutter and I used to battle about this, but he won me over. I'm almost much like James says. If it's anything beyond one Lambda function in my chain, go to step functions. Right. Yeah. If I'm triggering just one Lambda function, boom, boom, we're done. But like James said, you know, he doesn't really have error handling built into this yet. Whereas step function, you get that natively in a lot of ways. You're automatically going to get that, and it's just that, okay, if that didn't work, then go to here. So, yeah, and I encourage you to check us out next week. We'll be talking about this.
Yeah, this goes back to some of the sort of serverless approaches that really you have this toolbox with all of these different services. And there's so many ways to approach the same thing. I wouldn't say there's a right and a wrong way many times. And so it's interesting to try and swap out different solutions to see what works for you, because it really depends on the needs of your workload. But definitely, I wouldn't say that, you know, this is the absolute way you should always do it. You may find that you prefer to use step functions or SQS or SNS, just depending on what you need.
Right tool, right job. That's really what it comes down to. So we have this comment here, and I don't know what your thoughts is. Would depend on the use case. If it runs 24/7, the EC2 might be more cost effective. What are your thoughts on that?
Yeah, it might be. So, and this is one of the difficulties I always found when I was managing applications, is that if you can get a very even amount of work coming in, EC2 works wonderfully well. Yep. And if you can run at 90 to 100% CPU time, then it's very cost effective. The difficulty comes as soon as you move away from this even amount of work and things become more choppy, where you get different numbers of uploads. And you know, this I've talked about Netflix, but if you imagine social media platforms like Snapchat, when users upload videos, I'm sure that their amount of traffic being uploaded is extremely spiky. And the difficulty with that is that spiky traffic loads are just enormously hard to manage, because every time you try to do a scaling event, you're really behind what's happening out in your user base. And so I've really liked this type of solution because it takes that problem away. And when you look at cost, it's not just the cost of the EC2 instance of the Lambda function. You have to also factor in the cost of the headcount of people who are managing these things in your team, and the times where you get it wrong, where you're scaling up for events that then don't happen, and you're paying for compute resources that aren't used. So on balance, a lot of the time, the on-demand nature of this and the fact you're not paying someone to manage that scaling, can often be a benefit to you.
You're also not patching. You're also, all the things we talk about with, and I know it's a buzzword, but there's truth to it. Is this total cost of ownership?
Yeah.
How much is it costing you outside of just the infrastructure itself?
Yeah. So the great thing about this, this solution, although my code's not perfect by any means, the great thing is it's really extremely short. There's something like 50 lines of code or so here. They're doing the bulk of the work. Yep. And so when you think about the cost of running, having developers in your organization, it becomes a much more manageable and smaller task. And you factor in the code maintenance down the road as well. When I come back 6 months and I haven't thought about this, it's much easier to pick up the project again and understand what it did than if I have to understand configurations of DevOps behind the scaling. So there's pros and cons to these things, but generally speaking, I think this approach can be more cost effective overall.
All right, I have to stop the show for a minute. We've had a comment that I'm not sure that I didn't know. This is not true. It is 99% true, and mine is less than, I will agree. But I'm not saying James's code is always perfect. I don't know how much you paid this person, but that's a little ridiculous. I did like this comment here. Look, now people are jumping in. Saying, knock it off. I will end the show. I will pull the show over. I did like this comment. Then the guy that built the EC2 cluster quits, and you have no idea how it works in detail.
Yeah. I will say, so my code, I'm very confident on my code when there's very little of it. And it's one of the great things I enjoy about serverless is the fact I do understand this sort of functional programming model where the code comes to life, it's got some sort of input, it's going to do something and then go away. And so I found that as long as I've got very little code, I can write very, very reliable applications. And so it's one of the things that draws it to me. I'm not a super awesome developer. I've worked with many people who can write thousands of lines of code, and it's way more elegant and beautifully structured than mine. But I'm not bad when there's very little code.
Somebody posted this, though. I thought that was really cool. Thank you, whoever posted that. I appreciate that.
Yeah, I think a lot of it comes down to picking up also other parts of code that you've used before. So a lot of the things in here, if I'm starting a project where I'm building from taking objects from S3, I have functions where I've done that many, many times, so I can cut and paste there. Or if I want to build the S3 to Lambda integration, I can go to Serverless Land patterns, pull down the SAM template, and build that there. So really a lot of it, I'm not starting from scratch. I'm just using what either I've already written or somebody else has written.
That's right. Did you read that? I like that. Someone asked, am I still being force-fed healthy food? I haven't had Dr. Pepper this morning, but yeah, I am I'm better. I'm at like 95%. Yes, my wife is still making me eat healthy. I guess that's not a bad thing, but I appreciate your concern. Thank you very much.
I'm on my 10th day of no coffee, so
wow. If you only knew, that's pretty impressive. Now he hates everybody, but and say a little prayer for Wendy, but go on.
Yeah, I can also show you this SAM template as well, actually, because I didn't step through this in any detail, but this was something I pulled down from Serverless Land patterns. I started with an S3 to Lambda pattern, and I added some parameters just to provide some default bucket names I wanted to use. And the reason for that was that I remember my front end used these bucket names as a way of anchoring into the content. So I wanted to provide that those fixed bucket names. And then I wanted an option for anybody running this to generate frames or not generate frames. And the reason being is that it generates a lot of frames. You've got over 20 every second of video, and you're charged for S3 puts. So if you set that to false, it won't generate the frames. We'll get a sense of what's happening. And then the snippet size is set to 30, but you could set that to almost anything you want. And then I deployed that layer using the serverless application repo. So I just provided the arm here. And then once I got into this, the S3 bucket resources are just very simple resources with the names that I provided. then you've got your two functions. So you've the snippets function and the GIFs function. The snippets function is the part that chunks up the work. And so that's taking, the GIFs function is taking the work. Those take the arns, take the variables, and I've used these SAM managed policies to set the read or write policy on the various buckets, depending what I need. And then those are the rules that are, or the events that are triggering the Lambda functions from EventBridge. And so really what's that, 90 lines of code? And that's the SAM template.
And that's in the repo that you posted, right? Which I'm posting again right now.
Yes.
So
it's
so if you want to look at that, how that's done. Now, DM, I'm going to call you out. I have a bone to pick. Can you go back to your template, please?
I can.
Why are you manually naming your buckets?
Yeah, so a couple of reasons for this. Really, one is that I needed to know the bucket name for my solution when I was building this front end piece, because I have this hosted part. So I didn't want the bucket name changing as I was changing the project. And so I added it in that way. Okay.
So I would recommend that unless, and that makes sense, but the general rule of SAM is try to let your SAM name your buckets or you will run into collisions. If one of you runs this template right now, it will collide with James's. So you'll need to change that name. Well, pass in a new one. That's why I did it in parameters. So that makes total sense. That's acceptable, James. I forgive you. So just throwing that out there. But for most time, really let the template name your resources anytime you can.
Yeah, definitely.
All right. So we had, view build, you can provide, yes, you can. So with view build, you can definitely provide parameters. James and I are both huge view fans. Mm-hmm. We do parameter files, and you can pass those in. So
yeah, and you can deploy the front end from the repo. It's in this front end directory. I just stood up this public one. So if you're running just the back end and you didn't want to deploy a front end, if you provide your bucket name and your file name here, it'll do the rest. So as long as your backend is running, you can plug in your own parameters here and still see the results of the work.
All right. What other questions do we have? There's a lot going on here, and we got him on the hook right now. So any questions you may have, or James, you've got more you're going to show.
Yeah, I think so. Some of the things to get to in a little bit of the detail here are this download from S3 aspects is worth thinking about. So this is one of the things that was initially a little bit tricky, because if you use something like a get object call, you end up with a buffer. And that's great because then you can essentially use the entire amount or close to the amount of memory that you have set for your Lambda function. You don't need to download to a temporary location. You can also use a signed URL to do the same thing if you want to use an HTTPS call as well. And so it depends on which library you use for FFmpeg. So there's different ways of doing that. And I walked through a couple of them. So if you'll notice that if you go into the code, oh, that's the front end, wrong code there.
We got a couple of questions coming in that we'll jump to in a minute. So I'm not ignoring you, but I'm going to let James explain this first. So.
Great. So there's an NPM library you can use instead of using the command line approach, which I've used here. And there's a subtle difference in the way that you provide the S3 objects. So if you use the NPM library, you can download it using a signed URL of HTTP. If you use this method I show here, where effectively I'm constructing a command line and then sending it to this function up here, then submits the command line, then you can use the first approach. So, the key thing that is important to me here is making sure that I can use this free data transfer from S3. Because remember, if you've got 10 megabytes of video and it's going to 100 different Lambda functions, that's being downloaded to 100 different environments running your function. So that was an important part to point out.
Yeah, and I think that'd be easy to miss. I hadn't caught that. What's the library you're using for that?
So I'm not using library in here. This is just the method where I use the command line. But there is actually this alternative. I shall show you.
Yeah, I know I've seen.
In many cases, this could be a better choice for people because you're not constructing a command line and you have methods to be able to interact with FFmpeg. It's essentially a wrapper for the same library.
Gotcha.
So you still need the underlying binaries, but it provides a more elegant way for you to interact with this within your code.
Okay. So we had a question. Are you using Amplify to deploy your front end?
I am using Amplify hosting, yeah. So
Always.
yeah. It's great. It's basically, I point it to this repo, and it has the authentication to log into my repo. I select the backend folder, sorry, the front end folder for it to deploy. And then in this case, I've got a custom domain name. So I've got this domain jbez.dev. Any of my just test projects, I use a subdomain. And so I can tell Amplify Hosting about the subdomain, and it then goes and gets the certificate and maintains that for me, which is fantastic. But it also listens to the repo for any time I make changes and redeploy this. So a great example is when I forgot to put the GitHub link on this button up here when I first launched the blog post last week. And I was able to go into here and simply change the URL directly in the GitHub console without even going through the code. And I then 2 minutes later had an updated front end. So to me, Amplify Hosting is the absolute best way to deploy your front end Vue application.
I would tell you 99, probably 100% of the time, if you ask us where we're deploying our front ends, it will be Amplify console.
Yeah.
We get our CI/CD right out of the box. We get testing. Because we use Vue, it automatically recognizes that it's Vue. It handles, like James just explained, customer domains, SSL. It's literally a couple of clicks. You can even do it through CloudFormation if you're really ambitious. Yeah. So that's the one of the few times that I don't do something through infrastructure as code, because those are one-offs. Yeah. So we had a question. Go back to the Sam. Could you let Sam create the bucket name and store it in a parameter store? Absolutely. Yeah. Then front end looks up the name from the parameter store. That's absolutely, a possibility. It's probably a little overkill for just the bucket name itself. It could be something as you put it in your outputs when you deploy it, and your outputs update a local file for your client as well. But yes, there's multiple ways of doing that.
Yeah, honestly, if in a production app, I would recommend using CloudFront as well, because the buckets can be kept completely private in that case. And then you simply have a distribution pointing to the bucket. I think that's a lot easier for the front end to work with. And I just didn't do that because it's a proof of concept application.
There's another question here. Does Amplify now support Nuxt.js?
Yes. So Serverless Land is built using Nuxt, and that's how we deploy it. It's as usual with Nuxt, there's a fair amount of configuration in terms of getting the site exactly as you want it with Nuxt. Which, when we first built the site, we had to figure out how to do that. But once it got to that point, then plugging it into Amplify Hosting was really very straightforward. So in the way we've got this set up for Serverless Land, it's fairly elaborate, actually. So Serverless Land listens to a GitHub repo for the patterns that are generated. And when new patterns appear there, that triggers an initial build that clones the repo into another GitHub repo with the actual site code itself. And then Amplify Hosting that goes on and deploys the Nuxt site. So a couple of the things that we found when we first did it was you need to set up some rewrite rules for images that we weren't necessarily aware of. But otherwise, it was fairly straightforward. It wasn't difficult at all.
Yep, and yeah, if you have any other questions on that one, James is the genius behind it. Has done a lot of great work with Serverless Land. So really cool stuff.
Well, I started with knowing nothing about it. So it was, a lot of these projects, we started down the road of, should we use WordPress? Should we use Gatsby? Should we, we tried to take a fairly open, non-biased approach to different platforms that we wanted to use. Because even though we're serverless, we want to make sure that we produce something without creating a lot of work for people. And so we didn't know much about Nuxt when we started. And we found that from various other Vue projects we did, it was fairly easy to pick up. And then the theming was pretty easy to apply. So that's how we ended up going that way with that project. But obviously with a lot of these websites, it depends on what skills your own team has. Nuxt may not always be the best choice for you.
Right. Yeah, well, it's funny. We always start at level 0. So I'm kind of known as the API gateway nerd here. And when I started at AWS, I didn't know anything about API gateway. API gateway is hard. I mean, API gateway that's just a hard technology. I think Amazon does it great, but it's a hard technology. And so I just started learning it, man. You just dig into it, and that's anything else. So we always start at 0. That was a really good statement. So
yeah, I find with a lot of these projects as well, including this one, that I'm trying to set out with an end goal in mind that helps make it easier for developers to manage things. And I don't necessarily know how I'm going to build anything when I start. And I try different things. And so often with the blogs, you see the end result of what it looks like, but you don't see the 3 or 4 things I tried along the way that I thought might work, or, and I ended up taking left turns and moving things around. And so it really comes down to this toolbox we have in the serverless space of just being able to move around and pivot things very quickly. And definitely having less code makes that a lot easier.
Yeah. So here's an interesting question. And it's a little off topic, but it'd be interesting to see how we go. How would you use Amplify in case of a front end for both mobile and desktop versions that have different build artifacts? Can it redirect between domains based on user agent? I don't believe it can based on user agent. However, so one of the things when you use Amplify, it's automatically going to set up a CloudFront distro for you, right? It's going to handle all that. You could set up your own CloudFront distro that points to that. You can have, all right, here's my Amplify 1. So that's 2 different CloudFront distros, right? You use another CloudFront distro that would, because you can't manage that CloudFront distro. Mm-hmm. If you create your own, then you can use a Lambda at edge to, or look for headers, and you can route based on that. So that's how I would go. And it's just adding one more quick hop that get cached anyway. So you can route based on the header that way.
Yeah, I think you want to have a very good reason for doing that, though.
Yes. It's
like 9 times out of 10, it's probably better to have one application that manages both. But I can imagine for speed issues, if you need very, very high levels of performance, you might want to break them out this way. But I've been in projects in the past where it becomes fairly onerous maintaining sets of features in 2 code bases, and it's a little bit awkward to deal with.
So you're saying the client should detect the user agent and split, yeah. So it's a responsive site, yeah.
Yeah.
So
yeah. Now, one thing I wanted to talk about with this, so back on the GIF generator, GIF generator, I think we're going with. So one of the parts I was interesting is that how do you decide when a workload can be parallelized? So if you think about this, essentially, it doesn't really matter which chunk of 30 seconds of video is done first. They can be done in any order as long as they're done. And I started thinking down the road of, what other things can you apply this to? And so you definitely, when you take on these serverless tasks and you're trying to think about building solutions, I think anytime you have a Lambda function that may increase its running time, depending on the amount of work coming in, you might have a parallelizable task. It's worth thinking about what's causing the runtime to grow when you retrieve more work. If you're retrieving work from an SQS queue or something, potentially that can grow. And so I think that's a good first question to ask yourself. Can you break it down into these chunks? Because the benefit, is simply that the entire workload can then be done in a shorter amount of time than just allowing it to take longer for each invocation.
This is the first question that we ask. We have a lot, people come to us, look, I have a process that's longer than 15 minutes.
Yeah.
Can we get an extended time on Lambda functions longer than 15 minutes? Man, my first, and James just explained, the first thing I always ask is, does it have to be 15 minutes? Can we get it down to 1 minute by doing it in parallel? Right. And a lot of times you can. And maybe once in a while there is that process out there that is just not doable. But I would challenge that and say, a lot of times it can be, number one, can be parallelized to asynchronous versus synchronous.
Yeah.
So that you can start it and then get the answer back later instead of having a Lambda function churning for 15 minutes.
Yeah. One of the classic workloads is really with databases. If you look at RDS or relational style databases, where you have a job that comes to life and it's taking some sort of batch, like a day's worth of sales, and the sales start to grow and the amount of data starts to grow, you find that you're facing timeouts or whatever solution you have, cannot keep with the volume of traffic. And so solutions like that, to me, are often really good candidates for parallelization, where you can take much smaller batches more regularly and overcome the problem that way.
Yeah. So we had a question or a request. Conceptually, can you talk about Lambda parallelization? What does it mean? I mean, we've kind of thrown it around and you kind of gloss, or you talked about it earlier, but
yeah,
explain it to me, because I don't follow everything.
So if you think about it like this in a regular server that you have, not EC2, just a server somewhere. If you have a large amount of work that comes in, at some point the server cannot keep up with the volume of work, and typically work is lost or the server falls over or something bad happens in that sense. So in the Lambda space, that doesn't happen. What you have is internally, Lambda keeps track of the amount of work that needs to be done. So in the case of the S3 to Lambda integration, internally, there's this queue that exists that you don't see, where the Lambda service keeps track of all of the events that still need to be processed. Now, Lambda as a service, what it will do is it'll give any work that's available to any execution environment that already exists, and it's just idle for some reason. So if you've had a function that's been running recently and that execution environment is still running, the work will go there first. And that's to basically get the work done as quickly as possible. But in the event that you don't have any execution environments available, and there's all this work that needs to be done, it will then scale up. And so scaling up in this case simply means providing more execution environments with copies of your code running that will receive more events so they can start working on the work that needs to be done. Now, it's conceptually similar to the idea of scaling up with a fleet of EC2 instances, but I would argue it's just way, way different, because essentially what you're doing is going through a list of events that need to be processed more than anything else. And so we have some levers to control that scaling behavior. You might not want it to scale up that aggressively. You could use reserve concurrency to limit how fast it can scale, for example. But in many cases, you do want it to scale up. And so the great thing about this is all really built into that S3 to Lambda integration. It's not something you need to think about or worry about. You just need to make sure that you're writing code that can process those events and get the work done best it can.
Yeah. I would even in a simpler, it's taking, if I have 5 jobs that need to be done, rather than doing job 1, waiting for it to finish, job 2, waiting for it to finish, job 3, waiting for it to finish. You see that I'm up to 3 now. Job 4 and job 5. Instead, I say do them all at the same time. Do 1, 2, 3, 4, 5 on 5 different Lambda functions, rather than one Lambda function to run all 5. So instead of linear, you become parallel, and then and like James has explained, you write your code to handle that that way as well.
And actually, when you think about how your applications are structured, when I first came to serverless, I was used to writing applications where they're a mixture of short-running and long-running tasks. But because it's running on a server I've already paid for, I'm not really thinking about that too much. With Lambda, often I'm breaking things up into small functions that do discrete units of work, and some of them run faster than others. And by doing that, you get this ability to parallelize more effectively and building this sort of distributed system where you can get work done more effectively. But it took me a while to adjust to that. My first few applications were definitely much more like monolithic Lambda functions, like little servers running in a function. And I found I wasn't getting that sort of scaling benefit.
Yep. With that, we need to wrap. We are at time. Phenomenal session, James. As always, I love learning from you. A couple things. If you haven't seen it already, the cores configurator we put out a couple weeks ago. Excuse me. If you struggle with cores, cores.serverlessland.com. So that's pretty cool. Thanks. I appreciate that. You're talking about it. Yeah. Okay. Whatever. I will pull it over. So be sure to check that out if you haven't checked that out. We also have the Getting Started for Serverless. Man, if you're new to Serverless and you're like, whoa, what is all this? I really encourage you to check this out. s12d.com/getting started. Ben Smith puts that together. It's phenomenal. As well as Julian, if you've been doing Serverless for a while and you want to make it better and well architected, Julian has this killer series. I think like 21 blogs in or something. It's just crazy big series. s12d.com, well architected Serverless. And then James talked about the patterns collection, s12d.com. We've posted the blog, s12d.com/GIF1. We've posted several times in the chat if you want to see James's blog. There's another part coming out too, right, James?
Yes, part 2 comes out next Monday, so that'll be launching then. And just on the patterns, I just wanted to mention, we really want you to submit yours too. So this is a community effort. So we don't have as many CDK patterns as we like. So you'll see that big button in the top left on the page that says submit a pattern. If you have a pattern you'd like to send in, we'd love to see it. So don't be shy. That's
right. Always, what's new with Serverless? There's lots of new things coming out. I know I'm going fast because we need to wrap it up here. As well as new Serverless blogs. There's a whole new set of blogs since we announced last Tuesday. I mean, there's a lot of stuff coming out there. So I encourage you to check out both these. And with that, next week, we're going to be continuing this idea of parallelization, but this time with step functions. And how do we do this near real-time media conversation conversion in step functions? Julian's going to be hosting that with Prashant and Sandeep. So I encourage you, these are serverless here and a community builder. I encourage you to join us. And as always, if we didn't answer your question, hit us on Twitter, EDJ Geek or JBezW. JBezW. I don't know how to say that. But that's pronounced Bezic. I'll tell you that. So
it is.
With that, I hope you all have a great day. Stay healthy, and we'll see you next week. James, again, thank you, sir.
Thanks everyone for attending. Really great to talk to you. Have a great one.
See you later.